Welcome to Completing the Square. So in the previous lesson, you looked at how you could rewrite your graphing form or rewrite the standard form into graphing form by averaging the x-intercepts. We're going to look at another approach to doing this, and this will be especially helpful if your function does not factor or doesn't have any x-intercepts. So let's talk about how we can complete the square. So Jessica has this problem that she's working on her homework. She had missed class and couldn't remember how to complete the square. She was supposed to use that to change f of x into graphing form. So her little sister comes up and says, I know what they mean. So she explained f of x equals x squared plus 8x plus 10 would look like this. And she has this arrangement of algebra tiles right here. Okay, so what she then did is she took those algebra tiles and moved them around. So the x squared was in the corner, and then all of the x tiles ended up being placed in equal parts across the top and across the side. So in other words, beside to the right of x squared and below x squared, we placed the same number of x tiles. And then from there, she took all of the individual tiles, all of these unit tiles, and tried to fill in as much as she could that square. Now what happens is there's this sort of empty space here, all right? And what we have to do is we have to think about how many tiles are we actually missing there. So in other words, she took this expression and rewrote it like this. She said, I can see that this is a square that has dimensions of x plus 4 and x plus 4. So I can write it like this. Now the problem is I don't actually have enough unit tiles to fill up that square. So this is actually representing more than what I actually have. So what I need to do is I need to show that this has more than I would have, than I actually have, by subtracting the number of tiles that are missing. So in other words, I've got, if we look at how many tiles are actually missing, it looks like we're missing 1, 2, 3, 4, 5, 6. So I can rewrite that expression as x plus 4 squared minus 6. And again, that's because my square has dimensions of x plus 4, so it's x plus 4 times itself. But I'm actually missing 6 tiles from that expression. The number of tiles that I actually have on hand that I started with is actually 6 less than what this expression has. To check your work whenever you're doing a problem like this is to go ahead and graph both functions on Desmos or on your graphing calculator. If they come out to be the same function, then you know you did it correctly. So my original function is here in red, my completed in the square function is here in blue, and I can see that they are in fact the same. Okay, so let's try another one. So now Jessica has a new problem. She needs to complete the square to write y equals x squared plus 4x plus 9 in graphing form. We're going to try to draw the tiles this time and see how this works. So what I know is I have a single x squared tile. Okay, and then I know that I have 4 x tiles, right? So what I need to do is split them up so that I have 2 on each side. 1 or 2 that go to the right of x squared and 2 that go below x squared. So these are now my x tiles. Now, once I have that figured out, I can start looking at how many unit tiles do I have in this expression. It looks like I have 1, 2, 3, 4. So what I actually have here is x plus 2, if I'm writing the area model here, so this is the length of those sides, plus 2, okay? And I need to have a total of 9 tiles at the end here, right? So my original expression has 9 tiles in it. So what I know is if I just write x plus 2 squared, if I write x plus 2 times itself, within that I get 4 tiles. But my original expression needs 9. So I'm actually going to have to add on another 5 tiles. So that's going to look like this. Now, if I were to multiply x plus 2 squared out and then add 5 to it, I would get my original expression of x squared plus 4x plus 9. So let's try to make it a little more interesting this time. Okay, so this time we have an odd number as our middle term. We still have to create a square, which means we've got to find a way to get the same number of tiles to the right of x squared and below x squared when we're forming our square. So what Jessica decides to do is just cut them in half, and she ends up with an expression that looks like, or figure that looks like this. Okay, she has 2.5 x tiles to the right of x squared and 2.5 x tiles below x squared. So her square now has dimensions of x plus 2.5. Now, when you look at how many actual unit tiles you have space for there, you're going to see something sort of interesting happen. You have these 4 tiles, 1, 2, 3, 4, and then you have like a half a tile here, half a tile here, half a tile here, and a half a tile here. So what I end up with is this is one more tile, this is one more tile, and then at the very bottom here I have a quarter of a tile. So really what I have space for, if I were to multiply x plus 2.5 squared out, I would get x squared plus 5x, but then I'm going to have, like I said, 1, 2, 3, 4, 5, 6 and a quarter tiles. So this is what this expression would be if I multiplied it out. Now the problem is, in my original expression, I should only have 2 tiles. So if I wanted to rewrite x squared plus 5x plus 2 in graphing form, I could write it as x plus 2.5 squared, but then I have to remember that I only started out with 2 tiles, and if I just write this expression, I actually have 6.25 tiles. So here's what you can do. You can say, all right, here's how many squares I would have if I multiplied this out, okay? I'm sorry. Here's how many squares I have in my original expression. And now let's go ahead and subtract how many are actually in the square itself. So I have x plus 2.5 squared minus 4.25. And I can see that that's what I have missing from this square is 1, 2, 3, 4.25. So the way you can kind of approach this is whatever you come up with as your perfect square, if you add on whatever this constant term is in the original expression, and then just subtract whatever should be in this expression, you're going to end up with the correct adjustment. All right, so let's try one more. And maybe you're getting to the point where you don't need to draw the squares, and that's fine if you don't. There's nothing wrong with that. So this time I have an x squared tile. Now I have negative 3x. That doesn't change my approach at all. I'm just going to have negative 1.5 x on each of these. So negative 1.5. And I'm going to just write that up here because I can't fit it in the little tiles there. So negative 1.5 x tiles to the right and then to the left. And then I have my x by x tile here. Now what that means is that here, I'm actually going to have, this will be 1 tile, that's a half, and then this would be a quarter. Guys, here's an easier way of doing this. Think about it like this, okay? If I draw myself a square, here's what I know, right? I know, think of it in terms of like your squares you use for factoring. I know that this is x squared. I know that this is negative 1.5x on both sides, and then I can start to sort of fill in my expression. I don't need to draw out the algebra tiles every time. I can think of it more in terms of like a big box. So then all I need to do is I need to think about what goes here. And I get that by multiplying the negative 1.5 times the negative 1.5. And you're going to get negative, or not negative, you're going to get positive 2.25. So if I wanted to rewrite this expression, I could rewrite it as x minus 1.5 squared. Now I'm going to add the 10 on at the end, just like I would, because that's what I had in the original expression. And then I'm always just going to subtract whatever I put in the unit part of my box. So this right here. So I'm going to go ahead and subtract 2.25. Now, when I simplify that expression, that's when I'm going to get my graphing form of my quadratic. So I have 10 minus 2.25 is going to be 7.25. And I can sort of visually understand that I started out with 10 tiles and I rewrote my expression as x minus 1.5 squared. The problem is that only has 2.25 tiles in it, so I actually still have to add on the 7.25 tiles to get to 10. Okay, I'm going to give you one more to try, and I'm going to have you try it on your own, pause the video, and come back and check it when you're done. All right, give this one a shot. Pause the video, come back, and check your answer. Okay, so here's what I have. You can take a look at my square. I created my square by cutting that negative 9 in half to get the negative 4.5. And then all I did was multiply negative 4.5 times negative 4.5 to get 20.25. So then I knew that my expression was going to be x minus 4.5 squared, keep the original amount of unit tiles, and then just subtract how much was in the square that you just created. And so you get x minus 4.5 squared minus 23.25. Okay, so that's a quick reminder of how to complete the square. Go ahead and head back into Desmos and finish up the lesson.